Assalamu alaikum guys, welcome. Okay, so lecture 13 of this AS chemistry crash course. In the previous video we talked about empirical formula and molecular formula calculation. Now in this video we are going to talk about percentage purity. Okay, how to calculate the percentage purity of a sample. Percentage purity basically is a ratio of finding out the purity of a sample. Okay, for example, what is a pure substance? Pure substance by definition according to chemistry is a substance which is made up of only one type of element, right, or a compound. One type of element or a compound is called a pure substance. Now percentage purity means the percentage of a sample, percentage of a particular element of a pure substance in a sample. Okay, percentage of a pure substance in a sample. So percentage purity mathematically can be written as the mass of the pure substance in the sample divided by the mass of the sample times 100. This is how you calculate a percentage of the purity of a sample. Okay, and I'm assuming you guys have done this in O levels as well because it was a part of O level chemistry. Now a question has been given over here and I've used this example, solved this example to explain the concept of percentage purity. So let's get started. 3.2 grams of impure copper, okay, this is our sample. Okay, impure copper is the sample, was heated in air, and as soon as it was heated in air we got a 3.8 grams of copper 2 oxide as a product. So this means the copper must have reacted with the oxygen present in the air to form this product. Okay, now what is the percentage purity of the copper sample? Now guys, they've asked us the percentage purity of copper, not the copper oxide. Okay, percentage purity which was present in this impure copper. Okay, so now let's get started. Okay, copper, when it will react with oxygen, will produce copper 2 oxide. CuO is a formula for copper 2 oxide. Now and I balance the equation. If you look at this equation, what's the first step to do? The first step to do is we need to find out the mass of the pure substance in the sample. What is the sample? The impure copper. What's the pure substance? The copper itself is the pure substance, right? Copper is the pure substance and this entire impure copper is the sample. Okay, it must have copper plus the impurities. First step is to find out the mass of the copper. Then we already have the mass of the sample, which is the 3.2 grams, not the 3.8 grams. Okay, that's the mass of the product. We already have the mass of copper, mass of the sample, 3.2 grams. All we need to do is just find out the mass of pure copper. So for that we are going to use moles and mole ratios, that is known as stoichiometry. Remember, you've done the stoichiometry in O levels. Now first things first, we've got the mass of 3.8 grams of the copper oxide that is obtained, right? We can use that to calculate the moles of copper oxide, right? So the moles of copper oxide can be calculated by using the same formula which I taught you in the moles class. Moles is mass upon mR, right? So the mass which is produced, mass in grams, 3.8 grams divided by the mR of copper oxide. What's the mR? What's the molar mass of copper oxide? 63.5 is the mass of copper, the atomic mass, and 16 is the mass of oxygen. So the final answer is 0.0478 moles. Okay, you can use your calculator to calculate this answer. Now once you have the moles of copper oxide, you can use it to calculate the moles of copper. Okay, using moles ratio. If you look at this equation, 1 mole of copper, see there's just 1 written over here, there's nothing else written. Nothing written means there's a 1. 1 mole of copper produces 1 mole of copper oxide. That means the mole ratio is 1:1. So mole ratio of copper oxide to copper is 1:1. So this means the moles of copper oxide which are produced are the same as the moles of copper that reacted. So the moles of copper are also the same. Now once we have the moles of copper, we can calculate the mass of copper, and that's what we need in the sample. Okay, mass of copper in the sample can be calculated using the moles of copper in the sample. So you can just reverse the same moles formula. Remember, moles are equal to mass in grams divided by the molar mass, right? So if you need to calculate the mass in grams, how are you going to do that? You will take the molar mass and multiply it with the moles to get the mass in grams. So we have done the same thing over here. Mass of copper is equals to the moles of copper multiplied by the molar mass of copper, sorry, the relative atomic mass of copper. So once we multiply them, we've got the mass of copper in that impure sample. The mass of pure copper is 3.04 grams. We've got the mass of the sample. The impure sample is 3.2 grams. Now the 3.04 grams, you just is the mass of the pure copper. You just use this formula, get the percentage purity. Okay, the 3.04 excuse me, a 3.04 divided by the 3.2, okay, and multiplied by 100, and you've got your answer. This sample, the impure copper sample, is 95% pure. This means it has 95% copper inside of it, okay, and the rest of it must be some impurities with it. Apart from that, you could also use moles in this formula, okay. That is, this formula can also be written as the moles of pure substance in the sample, moles of pure substance divided by the moles of the sample. But usually this formula is not given in, not used throughout your syllabus, so you don't need to know it, okay, because the moles of the sample cannot be calculated that easily, right, because it has a lot of other substances in it. So just ignore that formula. This is the only formula you need to remember, okay, because the moles of the sample cannot be calculated, the total moles of the sample. It can be calculated if all the impurities are taken into the account, and then you are given a final answer. But anyways, this is what you've gotten, okay. Now in the next lecture we are going to talk about percentage yield. Thank you.